All right, so today we're going to be looking at multiplying decimals. And multiplying decimals as a concept is new for fifth grade, new for fifth grade pre-AP. But really, I'm going to show you that it's not so new, that actually we've been doing this for a while and we really know how to do it. And at first glance, it might look a little intimidating. I have 9 times 500ths, or 9 groups of 500ths. 3 times a tenth, or 3 groups of 1/10. 5 times 2500ths, or 5 groups of 2500ths, and 98 times a hundredth, or 98 groups of a hundredth. Now, some of these, you might be able to convert them from a decimal to fractions, because we did that a lot in our FDP unit. But a lot of the ones that we're going to encounter aren't going to play so nice. So it is helpful to know how to do this. Other than that, these are pretty easy when you consider the fact that we've really been doing this. You've seen these or very similar expressions since probably second grade. Some of us maybe before that even. And so I'm going to rephrase it slightly different. And so instead of 9 groups of 500ths, or 9 times 500ths, what if I asked you if you had 9 nickels? Because if I think about this like money, that kind of looks like nickels. So if I had 9 nickels, well then, yeah, that becomes really easy. We know if I have 9 nickels, then I have 45 cents. If I had 3 dimes, well, 3 dimes, that's pretty easy. That's going to be 30 cents. And if that makes you feel better to put a 0 there, you're welcome to. It doesn't change the value, so we can do that. 5 quarters. So if you had 5 quarters, well, 4 quarters is $1. I have an extra quarter left over. That's $1.25. And if I had 98 pennies, well, that's 98 cents. So really and truly, when you think about it, and I would say, well, congratulations, we just did our first decimal multiplication, but we didn't. We've been doing this for several years now. And so it kind of takes some of the mystery out of it. It's not so new. We've been doing this. And, well, what if the numbers don't play so nice? Or what if they don't have a coin? What if I have a decimal number that doesn't have a matching coin? Can I still do it? And here we'll go through some examples. And it says here, remember, multiplication is just repeated addition. So if I can remember, it's repeated addition, and that's pretty easy because we've known that since second grade when we first got introduced to multiplication. And so here I have 3 groups of 6/10. And so what we see here, I shaded in 6/10. 1, 2, 3, 4, 5, 6 out of 10. Right, because the whole rectangle represents one whole. So 6 out of 10, and then another 1, 2, 3, 4, 5, 6. There's my second group of 6/10. 1, 2, 3, 4, 5, 6. My third group of 6/10, and then I look, what do I have? I have 1 whole and 8/10. So 1 and 8/10 is my answer. Let's look at the next one. So the next one says 4 groups of 7/10. And so 1, 2, 3, 4, 5, 6, 7. There's 1 group of 7/10. 1, 2, 3, 4, 5, 6, 7. 2 groups of 7/10. 1, 2, 3, 4, 5, 6, 7. 3 groups of 7/10. 1, 2, 3, 4, 5, 6, 7. And sorry about the ketchup and mustard. Those are just the colors I had preloaded from when we did 2-color counters, so that's what we're using today. But 4 groups of 7/10. And so now that I've done that, I have 1 whole, 2 wholes, and then 8/10. So 2 and 8/10 is my answer. Let's look at the next one. 5 groups of 2/10. Alright, there's one group, two groups, three groups, four groups, and five groups. So my 5 groups of 2/10, and I have one whole. Next one. So really it's not too bad, right? 3 groups of 8/10. So 3 groups of 8/10. 4, 5, 6, 7, 8. One group of 8/10. 1, 2, 3, 4, 5, 6, 7, 8. 2 groups of 8/10. 1, 2, 3, 4, 5, 6, 7, 8. 3 groups of 8/10. I have 1 whole, 2 wholes, and 4 tenths. So 3 groups of 8/10 is 2 and 4 tenths. Moving along, 6 groups of 3/10. 1, 2, 3. There's 2 groups, 3 groups, 4 groups, 5 groups, and 6 groups. So 6 groups of 3/10 is going to give me 1 whole and 8/10. 1 and 8/10 for my answer. And the final one, 2 groups of 1 and 4/10. Well, a couple of ways we can look at this. We can go ahead and shade the 1 and 4/10, shade another 1 and 4/10, or the distributive property that we learned in 4th grade. So distributive property could look like I would decompose my 1 and 4/10. So I might have 2 groups of 1 plus 2 groups of 4/10. And so we could have done it like that in my distributive property in 4th grade. And then we know in 6th grade I can simplify that by simply having 2 groups of 1 plus my 4/10. I can still decompose it, have my distributive property there. That's another lesson for another day. But sticking with the way that it looks here, how I'm already familiar, let's go ahead and do that. So 2 groups of 1. So quickly just shade that whole 1. Another group of 1. And then 4/10 and 4/10. 1, 2, 3, 4. 1, 2, 3, 4. So 2 groups of 1 and 4/10. 2 groups of 1 plus 2 groups of 4/10. Or you could have just did it all, together. Either way, same answer. And what I'm finding that's going to be is 1 whole, 2 wholes, and 8/10 remaining. All right, good. So what? I've been able to do this, with my models, and hopefully we've seen the pattern by now. And if we haven't, let's see if we can find it now. Looking back at our original problems that we used to introduce this concept, here I have 9 times 5/100ths, but if I had 9 whole numbers, 9 times 5, what would my answer be? And that's right, 45. 3 times 10, 30, 5 times 25, that's right, 125, and 98 times 1, of course, is 98. Looks like I have a pattern here. 9 times 5 is 45, 3 times 10 is 30, 5 times 25 is 125, 98 times 1 is 98. But what if you said, well, what if I didn't add these here? Then I have 3 times 1. Oh, that's still 3. So it still works. Going back to our other page to see if the pattern continues. 3 times 6, is 18. 4 times 7 is 28. 5 times 2 is 10. 3 times 8 is 24. 6 times 3 is 18. 2 times 14 is indeed 28. So what I've noticed by now is that decimal multiplication is exactly the same as whole number multiplication, except I now have this little dotty thingy, this decimal. So I have a decimal in my problem. I know I'm going to have a decimal somewhere in my answer. Decimal my problem, decimal somewhere in my answer. My question to you is that really that different than what we did before? Because don't we have a decimal in every one of the numbers that we've ever used? Like this one here. If I look at my 5, where's my decimal in my 5? Right here. And if it makes you feel better, if I had $5, I could also write that as $5. And so there's my decimal after my 5. So even though I don't see it here, it is in fact there. So here I have 9 times 5. Well, it is 45. Where's my decimal? And yes, my decimal in my product is here at the end. 3 times 10. And here's my decimal at the end of my product. 5 times 25. My decimal is at the end of my product. 98 times 1 is 98. So we see that decimal is still there even when we were doing it before. So the decimal multiplication isn't really any different. It's not really that new. We've been doing it for years. We just didn't realize it. And so the only question that remains is, where does the decimal go? So I get it. I understand. I need to have a decimal somewhere, and it's just like regular multiplication. Where does the decimal go? So where does the decimal go? It's actually pretty easy. So what I'm going to do is I'm going to look at my factors. So I have a factor of 9, a factor of 5/100ths. And when I look at my factors, I just count up how many total decimal places I have. So here I have 1, 2 decimal places. So in my answer, I'm going to have 1, 2 decimal places, or in my product. Here are my factors, 1, 2, and in my product, 1, 2. Well, Mr. Ermenc, what happens if I didn't have that? Well, if I didn't have those zeros and I left it the way I did before, 1, 1. Oh, still the same spot. Here, in my factors, I have 1, 2 total decimal places, 1, 2, and the same thing, 1, 2, 1, 2. So really, it's just that easy. Step 1, I'm going to ignore the decimal. Step 2, multiply using my standard algorithm or your favorite multiplication method. And then I'm just going to count the decimals in place. So here I have 12 3/10 times 4. I'm going to ignore that and just pretend it's 123 times 4. 4 times 3, 12. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4. And I'm done, so I need to count up my decimal places. I have 1 decimal place in my factors, so I'm going to have 1 decimal place in my product, and there's my answer. We'll try it again here. I have 2 62/100ths times 11, so 1 times 2 is 2, 1 times 6 is 6, 1 times 2, tick, tack, 0, 1 times 2, 1 times 6, 1 times 2. Now I need to add my partial products together. That gives me 2, 8, 8, 2. And I just need to know, where does the decimal go? 1, 2 total decimal places, 1, 2, and I can place my decimal. Here I have actually a decimal in both of my factors, so I wonder what will happen. So first thing I'm going to do is ignore it. 8 times 6 is, so 6 times 8 is 48. 8 times 3 is 24, 25, 26, 27, 28. 8 times 4 is 32, 33, 34. Tick, tack, 0. 6 times 2 is 12. 2 times 3 is 6, plus 1 is 7, and 2 times 4 is 8. Add my partial products. That gives me 8, 10, 7, 8, 9, 10, 11, 12. 8, 9, 10, 11, 12. And I just need to figure out where does my decimal go. And so here's the cool thing. 1, 2, 3. I have 3 total decimal places, and in case you missed that. 1, 2, 3. 3 total decimal places. In my factors, 1, 2, 3 decimal places in my product. And does this answer make sense? Well, here I'm going to estimate. So 4 and 36 hundredths is close to 4. 2 and 8 tenths is close to 3. 4 times 3 is 12, so my product should be close to 12, and in fact it is. So that's estimating is a good way of checking your work. So here I have another where I have 2 factors, both with decimals, but here I have leading zeros. Now I'm going to tell you the leading zeros don't really do anything for us. You can multiply them if you want, but what's going to happen is you're just going to have a bunch of extra steps. So I'm just going to multiply, pretending those zeros aren't there. And if you think about it, we kind of did that here. 98 times 1 is 98, and then there it was, right? So I didn't really consider those zeros or multiply those zeros out, because anything times 0 is 0. All right, so here we go. 2 times 4 is 8. 2 times 2, 2 times 7. Tick, tack, 0, then 1 times 4, 1 times 2, 1 times 7. Add my partial products, gives me 8, 8, 6, 8, and I just need to know where does my decimal go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my decimal goes here, and I'm left with a gap, so I do need to put a 0 in that gap. And then also I'm going to recommend that we add an extra 0 just so that way it makes this decimal stand out, because math teachers tend to be old and blind, and I would hate for a teacher to be grading your paper, miss the fact that you wrote a decimal just because you didn't put a leading 0 and they didn't see it. So just to be on the safe side, let's cover that leading decimal with a 0, and we have our answers. And to use the estimating, just to check it, I have 7 tenths, so that's about 1, multiplied by a number that's pretty close to 0, and so my answer should be pretty close to 0, and in fact it is. So it all checks out, and hope that helps. If you need some additional help, feel free to email me or ask me, but that's your crash course on multiplying decimals.